Okay, so now let's continue on the after you know the equation of your BJT. So now let's continue on the IV characteristic of your BJT transistor. So here is the learning outcome for your BJT. So number one, we have learned about the basic structure of your transistor. So we have three terminal. One is your B, C and E. So 3 terminal, 3 currents. And how about the region of operation? So we have saturation, cutoff, and active. So in order to make it as an amplifier, it need to be in active region. In order to make it as a switch, it need to be in saturation and cutoff. So you also learn about the equation of your BJT. For example, IE equal IC plus IB. IC equal alpha IE and IC equal beta IB. Okay, so now let's move to the third part, that is to understand the current and voltage characteristic of your BJT. Okay, before we move to the current and voltage characteristic of your BJT, so let's recall back your IV for your resistor. So this is your I, V, and how is the shape of your the characteristic of the resistor is a straight line, means your I is proportional to V. That's where you got your resistor is equal V over I. So next you learn about diode. So what is the IV characteristic of your diode? So this is ID, VD, and the shape is after the V gamma. If you have your VD more than V gamma, your diode to start to become on. That is what we call forward bias, and here what will happen at your reverse bias means your diode is off. So now we want to learn what is the IV characteristic of your BJT, C, B, and E. So the mode of operation for your resistor, for your diode is either forward bias or reverse bias. But in your BJT, you have 3 modes that we call cutoff, saturation, and active. So let's see what is the IV characteristic of a diode. So in order to know what is the IV characteristic of a diode, so we need to identify, is it either common emitter, common collector, or common base. So how you're going to know this is common emitter? So we look at the input and output. So your input here is connecting to your base. Your output here is connecting to your collector. So what is common between your input and output is your emitter. So we call this one common emitter. Now what will happen at your common collector? Your input here is connecting again to your base, but instead your output is connecting to your collector. Now your output is connecting at your emitter. So your collector here is common with input and output. So that's why we call this one common collector. So in EECE 1312, we only focus on common emitter. Okay, so for common emitter, so how is the circuit of common emitter looks like? So if you see here, so we have CBE. So your input here is connecting to your base, and your output here is connecting at your collector. So means emitter is common to your input and your output. So this is what we call common emitter. So this is NPN circuit. How you know this is NPN? Because this arrow is pointing out. So between B to E, so if you look here, between B to E, you have a voltage what we call VBE. What is VBE? Is the minimum voltage required to turn on your BJT. Okay, because between B to E you have a diode, so we can call this in diode V gamma, but inside your BJT we call this one VBE. So let's say your VBE is 0.7. So then the voltage at your VBE here is 0.5. Will the diode be turned on or off? It will be off. unless you increase here to 1 volt and it pass across to the resistor, and 1 volt is more than 0.7, right? So then your transistor start to become on. Okay, so as shown here, this is the common emitter configuration for IV characteristics for NPN. So this graph is only for common emitter. So you have the output current here is IC, the output voltage here is VCE. Why? If you see the previous circuit, so this is the output voltage here. So this is your output voltage VCE. So your output current here is your IC. So your graph for IV characteristic here must be your IC. Here must be your VCE. So if you see here, so here is your IC. Here is your VCE, the output voltage and output current. So we know BJT have 3 operating mode: cutoff, saturation, and active. What happened during cutoff? So in cutoff, the transistor will be off. So when the transistor is off, there will be no current here. So that's why your output voltage here will be almost 0. So this region we call cutoff region. Now, during saturation region, means both here is your transistor. So in order to know whether this is cut off, saturation, or active, so we have here what we call BE junction. Another junction is BC junction. So when the transistor is cut off, both here will be reverse bias. So reverse bias means the transistor will off, your output voltage will be 0. This is your VCE, this is your IC. But what will happen when the saturation region means instead here become reverse bias, now here become forward bias. So your BE junction will be forward bias, your BC junction will be forward bias. Now what will happen when both are forward bias? So let's see here. So when both are forward bias, so here become forward bias and your BC also will become forward bias. Okay, so during the saturation region, when BE junction is forward bias and your BC junction is forward bias, so you will have a maximum number of IC but minimum number of VCE. So the region of the saturation is over here. So the rest of the region is what we call active region. So active region happens when BE junction is forward bias, but BC junction will be reverse bias. So this is what we call active region. So in order for the transistor to become amplifier, it need to be operate in active region. If we want to become switch, it need to be in saturation and cut off. Okay.